Hello everyone, this is Pranesh from SNS Institution, and in this video we will see about databases. Imagine you are running a college where you have thousands of students. You need to store their names, roll numbers, phone numbers, marks, attendance and other informations. If all this information is written in the notebooks, finding one student's details cloud takes several minutes. Updating information would also become difficult. Now imagine having a system where you can search for a student and getting required information within seconds. This is the basic purpose of a database. A database is an organized place where information can be stored, managed, searched, and updated efficiently. Almost every application we use depends on databases. When you create an Instagram account, your profile information is stored somewhere. When you order a food, your order details are stored. When you purchase something from Amazon, information about your product payment and delivery is stored. When you log into an application, the system checks stored information to confirm your account. Databases makes all this process possible. A database is not simply a large collection of information, it also provides ways to organize and manage that information safely. For example, a college database may have separate information for students, teachers, courses, attendance, and marks. These different pieces of information can be connected so that the system can be quickly find the required details. Databases are especially important when an application has thousands or millions of users. They allow applications to store large amount of information and retrieve it when it needed. Developers also need to think about the security because databases may contain sensitive information. They must control who can access, change, or delete without a proper database. Modern application would struggle to manage information efficiently. That's why we need proper database. There are different types of databases, but two major categories you will often hear about are SQL and NoSQL databases. Let us understand the difference using a simple example. Imagine a college student wants to store student information in a well-organized format. With an SQL database, information is usually stored in tables made up of rows and columns. A student table could contain columns such as student ID, name, department, and phone number. Each row represents one student. This structure makes the information organized and easy to connect within other tables. SQL databases are commonly used when the relationship between data are important. For example, a college student may have students, course, teachers, and attendance records. These tables can be connected through relationships. SQL stands for Structured Query Language, and developers use SQL commands to create, read, update, and delete informations. Now imagine a different applications where the information does not always follow the same structure. A social media platform may store different types of user content such as profile, posts, comments, images, and reactions. In such situations, a NoSQL database can provide more flexibility. NoSQL databases can store the data in formats such as documents, key values, pairs, or other structure instead of traditional tables. This flexibility can be useful for applications that handle large amount of changing data. This does not mean one type is always better than the other. The right databases depends on the application requirements. If your application needs strong relationship and structured information, SQL can be a good choice. If you need a flexible data structure and easy scaling for a certain workloads, NoSQL may be the best suitable one. The important lessons to understand the problem first and then select the databases that fits the requirements. Let us understand how a database works inside a real application. Imagine you are using an online shopping website. You search for a phone and the application displays its name, price, image, rating, and the stock information. All this information has to come from somewhere. The front end sends a request to the backend, and the backend communicates with the databases to find the required products information. The databases searches the stored data and send the result back to the backend. The backend then sends a response to the front end where you see the product on your screen. The same process happens when you create an account, place an order, update your address, or check your previous purchases. Databases also needs to handle many users at the same time. Imagine thousands of people buying product during a major sale. The database must process many requests without losing information or creating incorrect records. This is why developers care about database performance, security, backups, and reliability. Another important concept is data consistency. Suppose a customer buys the last available product. The system should not allow another customer to purchase the same item if it is no longer available. Proper database design helps prevent such problems. Developers also create backups so that important information can be recorded if something goes wrong. Security is equally important. Passwords and sensitive information should never be stored carelessly, and the access should be given only to the authorized users. A well-designed database is therefore much more than a place to save information. It is a foundation that allows on applications to operate reliably. When you understand how data is stored, connected, retrieved, and updated and protected, you begin to understand what happens behind almost every digital service you use. A good database design helps applications remain accurate, secure, fast, and ready to handle growth.